Welcome back to this Build in Public series where I'm documenting the entire end-to-end process of ideation to actually commercializing a software platform. If you missed the first episode, don't worry, I'll catch you up in just a second. So in the last video, I shared with you the inspiration behind why I'm building this application, which is a real-time translation app. And it all kind of stems from a personal issue that I've always faced in my life. Now, even more interestingly, on the date of recording, which is the 11th of September 2025, this week Apple just released an announcement, which was that their AirPods, their new generation of AirPods, is going to include real-time translation. Now, when I heard this was music to my ears. I did a little bit of research, and actually these AirPods are only going to support 5 of the most common languages on launch. So this didn't actually distract me from what I'm building here. If anything, this actually strengthened the validation of this idea. Because part of the problem is that there's so many translation services out there, but they only really support the most common languages. If you're trying to learn a language which is a local dialect or a more niche language within a larger region, such as Gujarati, there is almost no digital support for it, realistically, through apps like Duolingo or through services like what Apple is going to provide. So this just made me even more excited, to be honest, to be able to build this and to serve those languages which are currently being left out. So in the previous episode, as well as giving context to why I'm building this real-time translation app, I also was experimenting with some initial code to see whether this concept of real-time translation with a niche language was actually feasible. And in this episode, I'm going to be integrating that core technology into a backend server. This backend server will form the foundation of the application in the future. So whether you're following along for the technical deep dive or whether you just enjoy seeing how something is built, let's get into it. Okay, so let me walk you through this Django project. So from the previous episode, we were obviously working just with some scripts to start off with, and we were using a Vosk model with a model that we took alongside a model that we took from Hugging Face. So we're using Vosk for the speech to text in Gujarati, and then we were using a Hugging Face model to then translate the Gujarati to English. Now, to be honest, that was a bit ropey. It was very much a prototype, and I was quite happy with that prototype. But now I actually want to start making something which is a production grade, something that we can actually use in a production environment. So what I've done is I've created a Django project here, and for anyone that's not entirely familiar with Django, the documentation site is here. It's a really powerful framework for building backend servers. It has so much built-in functionality, things like authentication, object relational mapper, connections with like social logins like Google, for example. It has built-in functionality for languages and internationalization. It's incredible. So I'm going to be using Django for this, and it's specifically version 5.2. There's also some really nice documentation on here for starting your very first Django server. So within Django, what I've done is I have set up the project. So this is where all the project files are in here, like the settings and all that sort of stuff. And then I have included a new app within that project called transcription. And within the transcription, this is where I've included all of the updated files. So within Django, you can create apps, and then within each of the apps, you can then create separate views. And the views are essentially where you create your API endpoints. So to start off with, I've created some very basic views just to start off with. Basically just to sort of like list different transcription sessions, list specific transcriptions based on their ID, and so on and so forth. A health check view, that sort of stuff. Really, to be honest, this is just kind of like boilerplate stuff that I will definitely change in the future. It's really just to put some stuff in here. And then in the urls.py file, then I can basically point each of those views to a specific endpoint. So you can see here, based on the path that's provided, this is how you access these APIs. Within the apps as well, you can also set up models. So within the models.py, I've created several different models here. So every time a transcription session is opened, it will create a new transcription session object in the transcription session model. This is just going to capture some basic information to start off with. So when was it created? When was it ended? Is it currently active? And some sort of identifier for the user. On top of that, I'm also going to capture the tokens within the transcription session. So this will include the actual text, which session it came from, the language that it was spoken in, the speaker as well. Is this a final transcription? Because when you're doing transcription, especially on a WebSocket server, usually it is done as a streaming sort of like capability. So then you have the concept of partial transcription and then final transcription. So a partial transcription is sort of like an intermediate result, and then the final one is when it's been fully processed. A confidence score, and then a few other fields here as well. And then what we're going to do is we're also going to summarize the transcription as well. So we're going to have a summary of the original text that was transcribed and the translated text in the desired language, of course. Total number of tokens in that transcription, the duration of the transcription, and a few other fields as well. So these are going to be my database tables that I'm going to store data in as the WebSocket server is being used. And I just jumped ahead a little bit there. So with the views.py, this is where we're setting up API endpoints. So these are API endpoints where I make a request and I receive a response. Very simple. But because for transcription, we want a real-time response. We don't necessarily want to send one part of the speech that's coming in and then wait for a response and then keep doing that over and over again. What we need is a real-time connection. So what we're going to be using for this is something called a WebSocket connection. And Django, thankfully, connects with another really nice package called Django Channels, which allows you to set up WebSocket connections. And on top of that, we'll be using another tool called Daphne, which essentially runs the WebSocket server for you. So what this means is that rather than making hundreds or thousands of HTTP requests as the speech gets processed from the microphone, which would be completely intractable and completely inefficient, we'll create a single WebSocket connection, which is a connection that's maintained between the client, i.e. where the speech is coming from, and the server, i.e. the Daphne server in this point. It'll be a long-term connection that's opened where the two can communicate continuously. And that's how you enable real-time communication. So for this, we'll be using Django Channels, and we'll be creating a WebSocket server. And what I've done is I've basically just created a class for this WebSocket server. In this case, I'm going to call it the transcription consumer. There's a whole bunch of sort of like properties that I'm going to initialize at first, which are going to be used throughout the flow of the transcription session. And then there's a few handlers that we need to include. So we need to include a handler where the connection is opened. So when the connection is opened, we're going to initialize a few variables. We're going to set the API key, and we're going to start the session and essentially just send a message back to the client saying that the session is now started. We need a disconnect handler, so when the WebSocket connection is disconnected, and we need a receive handler. So this receive handler is what is going to be called when a message comes from the client and is sent to the WebSocket server. So in this case, the WebSocket connection is already open, and now audio is being streamed from the client to the WebSocket server. So this is basically what's going to happen when the WebSocket server receives incoming audio from the client. So there's a bit of validation of the data here, and then basically what we're going to do is we're going to decode the data into base 64 type, and we're going to send the audio data to a client. I'll explain what this client is in just a moment. And then we have a few helper methods at the bottom as well, where we're saving data in the database within the transcription token model. We're saving the summary and some other util sort of functions at the bottom as well. Now, with this consumer, as you may have seen in the previous episode, it was very basic and the transcription wasn't very accurate. So what we have found is another service that we can use, which is called Soniox or Soniox. Apologies if I've mispronounced that. But this service provides a real-time streaming API that allows us to stream audio to their service and get back pretty much in real time a transcription in Gujarati. And from my testing, this was working really, really well. So what I've done is I've created another class within this Soniox client.py file, which essentially initiates the connection to the WebSocket that they make available. So in order to use this, I needed to get an API key, but I'm really happy with how that's working. So rather than using the existing Vosk and Hugging Face model, which I'll definitely come back to at some point, but the key here really at this stage is prototyping as quickly as possible. I don't want to spend weeks and months fine-tuning a Hugging Face model to get it to work exactly how I want. I want to get to my endpoint as quickly as possible and then iterate and improve as much as possible. So for now, I'm going to leverage this Soniox service. So that pretty much explains most of the main updates in terms of this transcription and how we're going to set up this server. So we'll have some HTTP endpoints that we can access, and we'll also have a WebSocket server that we can access. So if I come back to the project folder and I go to URLs, you can see here that I'm routing to the transcription URLs in here, so that's good. We've also got the admin panel as well that we can take a look at as well. But for the WebSocket server, we have to create a separate routing.py file, and this routing.py file includes the WebSocket endpoints for the transcription consumer. So we're no longer going to be making a HTTP request to a WebSocket server, we're going to be making a WebSocket request to this endpoint. So /ws and then /transcription. This is where we're going to access our WebSocket server, which then sends audio in real time to Soniox, gets the transcription back, and does the translation. So a few extra things before I start actually running everything. Another neat little trick is that you can add management commands to your Django application. The first of which is this add test data management command. So basically what this does is this just loads my database with an admin user and any other sort of test data that I might want to include. The reason why this is really useful is because if you're testing and if you're iterating very quickly, you might want to destroy and recreate the database very often. And if you have to recreate all the data yourself manually each time, it's a real ball ache. So by adding a management command like this, you can literally just run this from the command line and it will create all the data that you need for you. So first thing that I'm going to do is I'm going to create the database. Now we are using SQLite because we're just experimenting locally for now. So I'm going to use the Python manage.py command and I'm going to migrate the models. This is going to create all the database tables, and now I've got my db.sqlite. I can even explore this as well. If I come up here and type in SQLite, I got a SQLite Explorer as well, so I can actually look through the tables if I wanted to. And you can see here I've got the transcription tables, so that's great. So now that I've got my database tables, now I can populate those tables with some data. So that management command that I created, I can call that by using the Python manage.py command and then literally just writing the name of that management command. Now this has failed because the management command is expecting some data in the environment variables, of which I don't have any of them currently in. So what I'm going to do is I'm just going to populate the environment variables file with some of these variables. This is obviously just test data and it's on my local computer, so it's safe that you can see them, but in production you would not want to expose these to the internet. I'm just going to give this the worst password possible. Fine. So now if I run this again, that completed. So now if I run my server, and if I go to the server in the web browser, I can now log in with this admin user. And I can see my admin panel, my admin tables. Obviously there's not really much here at the moment, so that's fine. So what I can actually do is, let's create a session. Let's just call this, I don't know, user number 1. We can't create anything here, so let's just save this. Let's see if we can create a transcription summary as well. No, it's automatically generated. I think these are all read-only fields, so that's fine. Transcription tokens. Let's leave that for now. But what I can do is I can actually test, now that I've added some data into the database, and if I go back to Visual Studio Code, refresh this, open up this table, I can see the data here as well, which is quite nice. So now I'm going to open up Postman and I'm going to test some of the views that we had before. So let's just get all the sessions. So I've created a Postman collection, I have created a folder for the transcription and the sessions, and I've just created this API request here. Now I don't think there's any authorization that's needed. Okay, it didn't like that endpoint. Let's have a look why. Okay, right. I think I know why. So we do have an endpoint for sessions, but then this path is appended onto the end of this path. And what I want is, I want this. So at the moment, that endpoint is pointed towards API/sessions, but I want it to be API/transcription/sessions, which is this endpoint here. So now let's try this, and this should work. No, it didn't like that either. Ah, okay. It's looking for sessions. Let's just get rid of the S on the end. And let's try that again. Okay, now we've got a response back. So this is basically calling this endpoint here, which is taking all of the transcription sessions. It's running it through the serializer class that I've created, which is essentially just serializing the model and giving it to us back in a JSON format here. So yeah, this gives us the metadata for this session. So that's good. The HTTP server is working. Obviously, we need to build on top of this as well and add a lot more functionality, but this is a good start. That's all working as expected. Now let's test the WebSocket server. Now, a WebSocket server is a little bit more difficult to test because you need a client to send a WebSocket connection request from. So in other words, like a web application, for example. But what I've done is I have created some files here to basically just test this WebSocket connection. And I'm going to run these. So if I just open this up, this is the HTTP server. We can just leave this open for now. I also added some helper functions in some helper code in the README file. So if I come to the WebSocket server, I need to run these two first. So I'm already in the server folder actually. So I just need to activate the virtual environment, which actually is already activated, so I don't need to do that. If I run this command, it will run the Daphne server, which is our WebSocket server, essentially. So this is now running, which is great. Now if I come into this folder here, and yep, I'm in the right directory. So now let's run this function. So let's run the WebSocket test.py file, and let's use this audio file as a test. And let's see what happens. Okay, error. What is the error? Okay, this is simple. It's expecting an API key, essentially. So what I need to do is I need to come over to my environment variable file and I need to add an API key. So this I am going to hide because obviously you should hide API key credentials. Or in fact, let's just test it with some gobbledygook for now. And let's just run this. So the WebSocket connection would have worked, but basically it's saying that, yeah, it's the wrong API key. So if I come in here and just find the location of this, and what I'll do as well is I'll just add a bit of code in here to make sure that the environment variable is loaded. So from .env import load.env. Okay, so now this will double make sure that the environment variables are loaded. Let's try that again. So I've now replaced the API key. Let's see if this works. Okay, it's still not playing ball. What I'm going to do is I'm going to initialize the API key on the terminal. So now I have initialized the API key on the terminal. So that should hopefully alleviate that issue. Now let's run the command again to run the test. Okay, so we've gotten to the root of the issue. Essentially, what we need to do now is we just need to run the command from the parent folder. And I've omitted the last flag as well. So if I run this, you'll see that the session starts, and it starts sending chunks to the WebSocket folder, WebSocket server, but then it fails. And if I come to the Daphne server, I'll see why it fails. So it actually has a problem connecting to the Redis instance. So, just jumping backwards a little bit. In order for a WebSocket server to run, it needs to connect to some sort of like caching server. And one of the most common ones to use for that is Redis. Now, whilst we're running locally, the way that we run Redis is we can run a Docker container that has Redis within it. So if I run this command here, it will pull a Redis Docker image and it will name it Redis transcription, running on port 6379. And if I open up Docker, I can now see that this is running. So that's why the test was failing, was because it wasn't able to connect to the Daphne server. Sorry, not the Daphne server, the Redis server. The WebSocket connection had no Redis server to connect to. So now if I run this again, the session starts, it's sending chunks, this is perfect, and we're getting tokens back from the WebSocket server. So this test file that I just recorded, it does actually include some Gujarati. Once again, very basic pigeon speech really. But you can see we're getting back all the information from the Soniox server as well. We're getting back the start time, the end time, confidence score, if it's a final token or not, and some actual translations as well, some transcriptions. So yeah, this is perfect. This is exactly what we wanted. Here we go, look, some English transcription. My name is Aaron. So the WebSocket server is now also working, which is massive. This is huge. And let's actually see if this saved anything in the Django database as well. So if I just refresh this, yes, it did. So it's saved a whole bunch of different sessions now. And I can actually see from the Django list view that it actually saves a number of tokens and speakers as well. So if I open up this session, yeah, it's transcribed it. This is the original text in Gujarati. This is the text in English, and it's saved this in my database now. I can see that there's a summary that's associated with it as well, and all the individual tokens too. So this is amazing. This is exactly what we need really. And this is really just the foundation and the start. So just to kind of go over what I've showed you throughout this session, I've showed you the overall structure of the Django project. I've separated it out into applications. I've showed you how the HTTP views are laid out as well, and this will be really useful for the front-end application that we build too. But then I've also dived into a little bit of detail about the WebSocket server, and in particular the Django Channels WebSocket consumer that we've created. This WebSocket consumer is a real-time connection that the client can connect to, and in turn, when the WebSocket connection receives audio that's being streamed to the WebSocket connection, it will then automatically stream that to the Soniox client, which is also expecting a stream of data. And the Soniox client will then send back in real time a transcription and a translation, which is amazing. So that wraps it up for this episode. But what we've essentially built is really the foundation of everything that will come going forwards. So now that we've got a pretty solid foundation, which we'll keep improving and building on, of course, in the next episode, I'm going to start bringing this application to life with a front end, and we're going to be building the front end using React. So now you'll actually start seeing this project taking shape on screen visually, rather than just through tests and through API calls. So if you're enjoying this series and you're enjoying seeing me build something completely from scratch, then don't forget to like, subscribe, and turn on the notifications as well, so that you'll see when a new episode comes out. Let me know what you're building too. I'd love to hear some of the ideas that you want to execute on as well. But for now, I'll see you soon.